Now we're only increasing the difficulty a little bit. It just looks more complex than it is. What you can have is a situation where you have x confined between two numbers, or we have x moving outward from an empty space. All right, that's the or situation, the and situation. Or we're going to have two arrows that kind of point away from each other, and we're going to have two arrows that hit each other, so you don't even see the arrowheads anymore. It's just going to look like a line segment when you're done. It's completely proper to write the word and. However, you'll notice your book just writes it as a compound inequality where they don't repeat the x. But these two things, I just want to write it both ways for you, are identical. The way you would read this is negative 3 is less than x and x is less than 5. So you would read it the same way I wrote it up here with the x repeated in the and sign. But same basic philosophy. You're going to write yourself a number line. We're going to put 0 for context. On these, since you have two numbers we're dealing with, it's really helpful to put both numbers on there. All right, so let's start with the negative 3. Is that on the left or the right? The left. All right, the negative 3. And scale, I'm not going to get there with a ruler, but it is important to note which value is further from 0, negative 3 or positive 5. Positive 5. So when we go to the right for 5, this is how far we'd probably go for 3. Let's go a little further so it's obvious we know that 5 is more than 3. The next thing we do is take care of our circles. These symbols tell us that both circles are what type? Open. So above each number, I'm going to write an open circle. And here's where people get totally messed up. All right? Because everything we've seen before, the conventional way of writing it, so we always put x on the left. So if you want and it helps you, rewrite this as x is bigger than negative 3 because that's identical. All I did was flip everything backward. Or you can always just go off of the right-hand point and know it either has to connect or go away from each other. If we know x is going left from 5, it can't also be going left from 3. That wouldn't really make a lot of sense, right? But according to this, it's also going right from 3, and they're going to meet up. And we have this contained line segment. And that's our answer. Everything in between but not including negative 3 and 5. So for instance, would the number 2, could x be 2? Yeah. Could x be 7? No. Negative 1? 5? No, because that's the open circle. Good job. All right, on B, we'll get our number line. Here's our 0. I'm going to say 2 is right here, and 7's even further right here. Both of these are closed circles. But on this one, it's obvious to us that x goes left from the 2 and right from the 7. So x is most numbers, it's just not those numbers in between 2 and 7. Negative 1, can x be negative 1? Sure. Can it be 4? No. Can it be 7? Yeah, because it's a closed circle. Any questions on A or B? Yes. Did you understand just this part right here where I switched that over? So what we're doing is we're graphing them both independently. So this one is going this direction, right? This one's going this direction. But because they both have to be true, it says and, we can't go past the negative 3. Right? Because it says that it has to be both bigger than negative 3 and less than 5, which is only the space in between. And once if I kept drawing this arrow all the way over here, now I'd be making this part false. Does that kind of make sense? Yeah. Okay, why don't you guys try C and D?